Okay, we are back and we're going to talk about powers a little bit, exponents, those sorts of things. So, negative powers. Most of these are about powers, you know, but a little bit about what negative powers do. They move things from one side of a fraction to the other. So, 2x to the minus 9, what's that? A negative exponent means take this whole thing, the x to the minus 9, and move it down to the denominator, where it shows up with a positive exponent. And likewise, say you had 5 over 4x to the minus 9. Again, the minus in the exponent means move it up to the other half of the fraction. So now we have a 5x to the 9th, and it shows up with the same exponent, the same number, but with a positive sign. Okay, so move things back and forth. What about exponents and parentheses? So powers and parentheses. What do we do with this? Well, suppose we have a to the minus 3, b to the 4, quantity cubed. Now there's a number of ways to deal with this. Often deal with the negative signs inside the parentheses first. So we have big parentheses, the cube is outside, we have a b to the 4th that stays in the top because it's got a positive exponent, and we have an a to the minus 3, and that goes down to the bottom, and that gives me a cubed in the bottom. So what about this 3? Well, when I have division or multiplication, no addition or subtraction is inside my parentheses. I can distribute the 3 to each power. So this becomes b to the 12th, because 4 times 3 is 12, and a to the 9th, because that's a to the 9. Because 3 times 3 is 9. So why can I do that? Well, b to the 4th over a cubed is, well, it's b to the 4th over a cubed times, and that's an a, not a 9, b to the 4th over a cubed times b to the 4th over a cubed. Right? So cubing something means multiply by itself 3 times. So how many b's do I have? Well, I've got 4 here and 4 here and 4 here. That's 12. 4 times 3, that gives me 12. How many a's do I have? 3 here plus 3 more plus 3 more, or 3 times 3. That's 9. So it's a little shortcut. If you've got no additional multiplication inside your parentheses, you can distribute the exponents. Right? And we can do this with various expressions. You know, suppose we had 5x squared y to the minus 3 to the minus 2. What is that? Well, there's no addition or subtraction inside the parentheses. It's all just multiplication. What I can do here now is I can just start by distributing the power, and it goes to every term that's in there, including the 5. So it's a 5 to the minus 2, and x to the minus 4, minus 2 times 2, times y to the plus 6. Minus 2 times minus 3 is 6. So the y stays up, the 5 squared, x to the 4th goes down. 5 squared we know is 25x to the 4th. And so that's how we can handle anything in parentheses. If we had 4x to the minus 2 over y to the 4th, all raised to the 1/2. Well, fractional power is just a number like any other power, so it does the same thing, right? 4 to the 1/2, you distribute it to each of these powers, because inside this parentheses it's all multiplication and division, no subtraction or addition. So you get 4 to the 1/2, x to the minus 1, because it's 1/2 times minus 2, y squared, because that's 1/2 times 4. Now, 1/2, that's the same thing as square root, so it's square root of 4. It's x to the minus 1, so that's a negative exponent, so it goes down to the bottom. And a y squared, the y squared is a positive exponent, so it stays in the bottom. And so we have 2 over xy squared, because square root of 4 is 2. So fractional powers are roots. Right? So, like we said, 4 to the 1/2, that's square root of 4, that's 2. 8 to the 1/3. Right? You may have seen this written with a little 3 there, a cube root of 8. Well, that's 2, because 2 times 2 times 2, 2 cubed is 8. So 8 to the 1/3 is 2. There are some other roots. The 4th root of 16 is also 2. 2 times 2 times 2 times 2. Well, if you have 4 2's multiplied together, that's 2 to the 4th. And if you actually do the math, it's 16. Cube root of 27 is 3. Square root of 16 is 4, you know that. Square root of 64, interestingly, is 8. The cube root of 64 is 4. So there's some various roots. And then we can stack powers, right? So we've seen if I have, say, a squared cubed, well, you just multiply these two together. That gives you a to the 6th. But if you look at it the other way, suppose we have 16 to the 3 halves. Well, 3 halves is 3 times 1 half. Right? And just like this here, a to the 6th, that's an a times to the 3 times 2, and it can be written as a squared cubed, or if you want, a cubed squared. Those both give you a to the 6th, because 2 times 3 is 6. I can rewrite this as 16 to the 1 half cubed. And now 16 to the 1 half, that's square root of 16, so that's 4 cubed, so that's 64. So if we have a fractional power, and I want to evaluate it without a calculator, you can break them up like that, and then you can figure out what that was. So one last example. What's 8 over 27? And let's make clear that that's an 8. 8 over 27 to the 2/3. Well, we can break up the fractional power. It's an 8 over 27, and 2/3 is 1/3. And then that whole thing to the 2. So 8 to the 1/3 is 2. Cube root of 8 is 2. 27 to the 1/3 is 3. 2 squared is 4. 2 cubed is 9. Okay, and so hopefully this is a shorter video than some of the other ones have been. We're trying to keep these things from being a little out of control. And so we'll stop here, and then the next set would be on, and I don't know why my screen is doing that. And the next set will be on quadratics, section A7.